Thanks to LEGO City Space for sponsoring this episode of SciShow Space. You were born to explore the universe, and LEGO wants to inspire the next generation of space experts through building and play. More people than ever are looking forward to the day we send humans to Mars. But if those first explorers are going to spend much time there, they'll need a lot of supplies. Food, water, air, and shelter are critical components of any expedition. But the problem is, they're also heavy. Some estimates suggest it might take as much as 225 kilograms of fuel to send 1 kilogram of stuff to Mars. And the more fuel you need, the more expensive your mission becomes. So what if instead of bringing everything with them, astronauts could live off the land? It sounds like sci-fi, but it could be possible thanks to the Sabatier reaction. It's a chemical process we've known about for more than 100 years, and it promises to create nearly everything a Martian explorer might need, literally out of thin air. This reaction was discovered in the late 1800s, and in 1912, it earned one of its discoverers the Nobel Prize. Its chemical equation says that if you combine carbon dioxide and hydrogen at several hundred degrees Celsius, you produce methane, water, and energy. Originally, this was just cool from a chemistry standpoint, and because methane is the primary component of natural gas, so being able to make more is handy. But in the near future, it could also transform Mars exploration, because this reaction is almost perfect for living on the red planet. For one, you wouldn't even need to bring one of the ingredients you need for this reaction. The Martian atmosphere is more than 95% CO2, so it naturally supplies all the carbon dioxide you could ever need. Unfortunately, there's far less hydrogen on Mars, so you would have to bring that from Earth, which could get tricky. But if nothing else, hydrogen is literally the lightest element in the universe, so you at least wouldn't have to worry about it weighing down your rocket too much. And besides, dragging that hydrogen around would be totally worth it, because if you have methane, water, and energy, you have almost everything you need for a Mars colony. The energy produced through this reaction could be turned into electricity or heat, or it could be used to keep the Sabatier process going. The methane could be used directly as rocket fuel when combined with liquid oxygen. And finally, the water produced could be used for drinking, farming, or rehydrating stored food. Astronauts aboard the International Space Station actually use the Sabatier system to provide drinking water, so this part isn't just theoretical. Still, on Mars, the water wouldn't be just for drinking or agriculture. It would also be used in other chemical reactions to produce an even wider range of substances. For example, we could use water for electrolysis, a process that uses electricity to break apart molecules. In this case, it would break water into pure hydrogen and oxygen. The oxygen might be used to create a habitat's breathable air, while the recovered hydrogen could start another round of the Sabatier reaction. Alternatively, we could combine the water with more carbon dioxide from the atmosphere. If you add some electricity to that mix, you get ethylene gas. Ethylene has many industrial uses, but Martian explorers might be especially interested in its agricultural properties, where it could be used to promote plant growth and help fruit ripen. This gas could also be compressed into a solid form, which is called polyethylene and is the world's most common form of plastic. So yeah, with CO2 from the atmosphere and hydrogen from home, you can ultimately make plastic, because this reaction is the best. Unsurprisingly, plastic would have almost unlimited use when setting up a habitat on Mars. After all, with the help of a 3D printer, it can be turned into nearly anything. But it would also be especially useful for building the habitat itself. A major obstacle to long-term habitation on Mars is the radiation environment. Because the planet has a much thinner atmosphere and lacks Earth's protective magnetic field, a mission to Mars would expose the crew to up to 10 times more radiation than on the ISS. So the crew would need to take steps to protect themselves. On the atomic level, radiation is often blocked not by physical collisions, but by electromagnetic interactions. Because of that, the best radiation shields have the most electrical charge in their nucleus relative to their weight. That's where polyethylene comes in. Hydrogen atoms have the highest charge-to-mass ratio of any substance. So because polyethylene is full of hydrogen, it effectively absorbs radiation. And that makes it an ideal building material for the Martian surface. So as long as you bring a bunch of hydrogen from Earth, there's a lot you can make for yourself on Mars. You can get water to drink, air to breathe, fuel for your rockets, energy to power your equipment, ethylene to help with agriculture, and plastic to build almost anything. That's a pretty sweet deal, and one of the most encouraging things is that we could start doing something like this if we send people to Mars today. There are some things that would require bulky, specialized technology, like plastic production, and there are some efficiency problems to work out since the Martian atmosphere is pretty thin. But none of this is technologically impossible. If we have the will to do it and the resources, we could probably get it done. And it's never too early to inspire the engineers who will one day do the job. This episode is brought to you by LEGO City Space, who wants to help do just that through building and play. LEGO City Space is a great way to celebrate past space accomplishments like the moon landing and look forward to future goals like moving on to Mars. We don't know what's ahead, but we can prepare to build on everything that's come before. We used kits like the Space Research and Development People Pack, Deep Space Rocket and Launch Control, and the Rocket Assembly and Transportation sets to help envision life on the Red Planet. Click the link in the description to start exploring Mars with LEGO City Space. Let's go!